everyone, welcome back. It's great to have you here today. In this video, we are going to go through 5 EMC style questions. I recommend trying these questions yourself first. You can find the link to the question in the description box. If you need to review the content before attempting these questions, this playlist might also be useful. Okay, so let's get started on the first question. In this question, we are told that this circle is centered at the origin, and AB is a tangent to the circle at point A. So then that means OA is perpendicular to the tangent, because OA is the radius. Angle OBA is 30 degrees. Point B has a coordinates of 16, 0, so then that means OB is 16. Point P has a coordinates 3P, P. And then that tells us OP equals OA because both of them are radii. And now what we need to do is to work out the value of P. So what we can do here, as we can see, there is a triangle, a right-angled triangle. Therefore, I'm going to copy out this right-angled triangle and label them just so that we can see what information we have. So as we can see, it's a 30-degree angle. The hypotenuse is 16, and we need to work out the opposite. We know h times sine 30 should give us the opposite. Sine 30, we know it's a half, therefore the opposite should be 8. So that tells us the radius is 8, so then that means OP should be 8. From OP, we can see that there is also a right-angled triangle. The horizontal distance is 3p, vertical distance is p, and the hypotenuse is 8. So here we can use Pythagoras theorem to work out the value of p. And then because we know this point is in the first quadrant, therefore p is greater than 0. Therefore p is 2.5 rounded to 1 decimal place. Okay, now moving on to the second question. In this question, we are given the equation of the circle x squared plus y squared is 4. And then from here, we can tell that the radius is 2. Let's quickly get ourselves a sketch just so that we can visualize the problem. P is a point on the circle. There is a tangent to the circle at point P. So what we need to do now is to find the equation of this tangent line. The general equation of a straight line is y equals mx plus c, where m is the gradient. As we mentioned earlier, tangent and the radius are perpendicular. Therefore, this gradient is the negative reciprocal of OP. So that means we need to work out the gradient of OP. We know the coordinates of O, which is 0, 0, or coordinates of P. To work out the gradient, we need to do change in y over change in x. And that gives us root 7 over 3. Therefore, the gradient of the tangent line should be negative 3 over root 7. And if we rationalize this, that gives us negative 3 root 7 over 7. So we know the equation of this straight line should be y equals negative 3 root 7 over 7x plus c. And p is a point on the straight line. Therefore, we can substitute this point back into the equation, and that helps us to find the value of c, which is 8 root 7 over 7. So, as a final answer, the equation is y equals negative 3 root 7 x over 7 plus 8 root 7 over 7. Okay, so moving on to the third question. Now, in this question, we are told that CAD is a tangent to the circle at point A. Therefore, OA is perpendicular to CD because OA is a radius. And we need to work out the angle CAB. So from this question, we can work out the angle of AOD by using the fact that angles in a triangle add up to 180. So then we know it's 58 degrees. After that, we can work out AOB, which is 180 subtract 58. 122 is the angle of AOB. Since we know AOB is an isosceles triangle because OA and OB are radii, therefore angle OAB is going to be 180 subtract 122 over 2, and that is 29 degrees. After that, we can work out angle CAB by using 90 degrees take away 29 degrees, and that leaves us with 61 degrees. And that is our final answer. And this is how we work out the angle CAB. I'm going to write the working down just so you know how to lay out your working. And always remember to give a reason for your working. Okay, so now moving on to the next question. In this question, we are told that AOB is the diameter, and we need to work out ACB is 90 degrees. Now, in this question, we can't use any circle theorems. So what we need to do is to start from the beginning. Okay, so because we know OA, OB, and OC, they are radii, so they equals to each other. So then it tells us AOC and BOC are isosceles triangles. Therefore, if we call OAC X, ACO should be X as well because it is an isosceles triangle. Similarly, if we call OBC Y, we know that BCO is also Y. We need to use the fact that angles in a triangle add up to 180. Therefore, we have x plus y is 180. Simplify that. We have 2x plus 2y is 180. Factorize out 2 and divide both sides by 2. We will have x plus y is 90 degrees. And x plus y is our angle ACB. Therefore, we have finished the question. Okay, now moving on to the final question. Angle ABD is 20 degrees. BAD to BCD is in the ratio 3 to 1. Therefore, angle BAD could be 3x. Angle BCD could be x. And what we need to work out is angle SBA. Now, as we can see, SBA and angle ADB are equal because of AST. Therefore, what we want to do is to work out angle ADB. First, we know quadrilateral ABCD is cyclic. Therefore, we know 3x plus x should be 180. Then that tells us 4x is 180. X, therefore, is 45. So we can work out BAD, that's 3 times 45, which is 135. Then we can work out angle ADB is because angles in a triangle add up to 180. Therefore, ADB is 25 degrees. And now we can conclude SBA is going to be 25 degrees as well, because of AST. That is it for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport. You have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.